All right, welcome. This is Unit 3, page 6. We are going to be just filling out some of the back information. Yesterday, you took notes on page 5 to help you with doing some of putting the things together, y-intercepts, x-intercepts, vertical asymptotes, horizontal asymptotes, and getting some points. So on page 6, let's just fill in some information here. To find the y-intercept, set all x's equal to 0. So plug in, this means plug in 0 for all your x's and solve for y. Alright, to find the y-intercepts, this means set y equal to 0. So this means really the function is going to be replaced by 0, and then you're going to solve for the x. So, in all actuality, when you have a fraction like this one down here at the bottom, when you replace the 0 in here for the f of x, when you cross multiply, that actually cancels out the whole entire denominator. So really, that means set the numerator equal to 0 and solve. The vertical asymptote, set denominator equal to 0 and get x equals what, or whatever the number is. Make sure in the asymptote you have the equation x equals for verticals. Horizontals, we compare the degree of the top and degree of the bottom. Okay, so with that, if the top is smaller than the bottom, we automatically say the asymptote is at y equals 0. If the top is equal to the bottom, we take the leading coefficient of the top over the leading coefficient of the bottom. So that's y equals the top, then those two numbers over each other. If it simplifies, simplify it. If it doesn't, don't worry about that. And if it's the reverse, if the top is bigger than the bottom in terms of degrees, we have new horizontal asymptotes. In a few days we'll get into the slant asymptotes, which is when this case will happen. The top is bigger than the bottom, but it's going to be only by 1 degree. Alright, so getting all that information down so you have it in one spot. Use those information if it's a pausing time and you're comfortable doing these, pause these and just make sure we match for a sec. You're going to have to be doing factoring. Some of you like to refer to it as master product sum. Some of it's just really factoring when you come down to it. So x over x plus 1. That's potentially the easiest way if you want to solve for the x's in the denominator, which would be your vertical asymptotes. You can do quadratic formula with just the denominator, but you don't have to. Factoring vertical asymptotes, x minus 2 equals 0 and x plus 1 equals 0. Okay. The horizontal asymptote, so the degree of the top, is 1. Degree of bottom is 2. And so the top is less than the bottom, so it's automatically y equals 0. Alright, so for the x-intercepts, so we plug in all, sorry, lost my train of thought. For the x-intercepts, we set the top just set the top equal to 0. So 0 is equal to x. So there's no solving to do, so you actually have your x-intercept right away. So 0 or at the origin. The y-intercept, you'd replace every single x with a 0. Okay, so 0 or 0. Alright, so let's get our asymptotes and stuff on there. Vertical asymptotes at 2. And -1. Horizontal at 0. Alright, we have the x-intercept and the y-intercept is actually the same point, so it's right here on the origin. Now, an asymptote is really, a line cannot cross it except when it is very, very close to 0. So this is actually at 0, so it is okay for it to cross the horizontal asymptote at very, very close to 0. So it's not going to cross a vertical asymptote, but the horizontal it can cross right there. Alright, next thing we do, we need to get some points here. Alright, so make a quick table because you are not going to have the graphing calculators when you do these. I'm going to bring in the smaller calculators. So if you know how to work with them, great. I will have them, so it's not going to be a surprise or anything, but you're going to have them in class tomorrow and Friday. So next thing, so I plug in some numbers. I'll plug in 1. So 1 will give me another point in here inside of my 2 asymptotes here. So I plug into the equation 1 over 1 squared minus 1 minus 2 over -2. So 1 and -1/2. 1 and -1/2. Now, those points, it's hard on this one because I don't have a third point without my calculator, which I actually don't have in here. I could do -0.5 in here because I don't want to do -1, it's an asymptote. But if I do -0.5, it will give me a positive value in here. So the calculators will be handy. We'll have them in here. You can work with them. Alright, so I need to do on either side of my asymptote here. So I have it at 2, so I need to check out like 3, 4, and 5, and then I need to check out on the other side -1, so like -2, -3, -4. Alright, so if I plug in, let's see, 3, 4, 5. So 3, it's going to actually give me like 3 over 9 minus 3 minus 2, 6, 5, 4, so 3 over 4. 4 is going to give me 4 over, plug it in, 16 minus 4 minus 2, 12, so 4 over 10, which is 2/5. Okay, take those points, so 5, and then I have 5 over 25 minus 5 minus 2, so 20, 18, 5 over 18. So these are some silly numbers, but we can do them. 3 and 3/4, so it goes up like to here, and then 2/5, and it goes smaller. So you can see it's going curving close to this asymptote here at 0, and going up here like this. Alright, so then we need to check out -2, -3, -4. So I'm just do a little bit more over here because I'm running out of room. -2, -3, and -4. And then you can see, so it's -2 over -2 squared, which is 4, plus 2 minus 2, -2 over 4, so -1/2. negative 3 is going to be negative 3 over, I ran out of space again. Negative 3 over 9 plus 3 minus 2. Negative 3 over 12 minus 2 is 10. Negative 3/10. And negative 4 would be negative 4 over, yes, I will give you plenty of room when you do these. 16 plus 4 minus 2, so negative 4 over 18, which is, no, over positive 18, which is negative 2/9, so even closer to the y-axis there. Okay, so two asymptotes, you got part in the middle, you got graphing part in the middle, you got a graphing part on the right, and a graphing part on the left. Now I'm going to get you started on the next one because it's going to combine a whole in it. So like this says, here's the function without a calculator. Do this using the steps above. Factor the top and the bottom of the rational function. So I need x squared plus x minus 6 over x squared minus x minus 2. I need to factor the top. X minus 2, x plus 1. Okay. We have these things that cancel out. X minus 2 cancels. So that means, what does this mean? X minus 2 equals 0, or x equals 2 is a whole. Alright, so the value for the x whole is at 2. And now I need to finish my graph, x plus 3 over x plus 1. This is what you are going to use to do the rest of the vertical asymptote, horizontal asymptote, x-intercepts, y-intercepts, and get the whole. So you plug in 2. 2 plus 3 is 5. 2 plus 1 is 3. So you got 2, and so this means what? 2 and 1.6 repeating. So at your graph, you will have a whole at 1.6 repeating. All right, fill in the rest of this stuff. Get the graph on there. Check it with me, and we'll go from there tomorrow. Thanks.